Hi, and welcome to the MyHeritage webinar series. I'm Jeff Rasmussen, your host, live at webinar headquarters in Middleton, Idaho. Today we will learn from Paul Woodbury on the topic of fishing in your match list with MyHeritage DNA tools. A syllabus for the class is available on the webinar's registration page, or it's at the bottom of your webinar control panel, and I'll put the link in your chat here in just a bit. From a young age, Paul Woodbury fell in love with genealogy research. To pursue his passion for this field, he studied genetics and family history at Brigham Young University. And to aid in his desire to share his knowledge with others, he has also received a master's degree in instructional design and educational technology from the University of Utah. Paul is an accredited genealogist in the France region through the International Commission for the Accreditation of Professional Genealogists. He currently works as a research team manager at Legacy Tree Genealogists. And that might even be now the DNA team lead, I think, where Paul has helped to solve hundreds of genetic genealogy cases. And in addition to genetic genealogy, Paul enjoys French research. So please put together your virtual hands. Let's give Paul Woodbury a nice warm webinar welcome. Paul, how are you? And welcome to the show.
I'm doing well. Thank you so much for having me, Jeff.
Nice to have you here and looking forward to the topic.
Yeah, this will be fun. I'm excited.
All right, looks good. It's all yours.
Wonderful. Thank you so much. And thank you to all of you for joining us today as we talk through fishing in your match list with MyHeritage DNA tools. This is a principle or an idea or a methodology, an approach, whatever you want to call it, that I've been playing around with and tinkering with for a while. And I'm excited to kind of share the underlying methodology with you in terms of using known relatives to help us isolate pertinent genetic matches. I've talked and hinted at this in some of my other webinars available through Legacy Family Tree webinars, and I'm excited to kind of go through some of the thought process and as well as the nuts and bolts of how to actually do this approach specifically at MyHeritage. So to start out, I want to just go through a few objectives of some of the things that I hope you will walk away from this webinar with. First, I'm hopeful that through today's presentation, you'll learn to consider genetic clusters within the context of known relatives. And we're going to talk about and kind of demonstrate how we can leverage those known relative relationships to really get the most out of our DNA match lists. We're going to discuss utilizing theories of family relativity as well as shared match hints for identifying independent descendants of a research subject. We'll walk through utilizing the shared match and labeling tools at MyHeritage to identify potentially pertinent genetic cousins. And then we're also going to go through some examples of how you might analyze that information to iteratively process potentially pertinent genetic cousins until you do find those matches who are not just potentially pertinent, but are pertinent to your research question. In a previous MyHeritage webinar, I gave a presentation. This was back in July 2020, so it's coming up on 3 years ago, a presentation on connecting the dots and introduction to AutoClusters at MyHeritage DNA. Today, we're going to be talking a little bit more about clusters and about how you can use clusters of matches to identify individuals who might be important in your research. So genetic clusters or genetic networks really are representations of the relationships between a test taker's DNA matches that are grouped or clustered into meaningful categories. There's lots of ways that you can generate these clusters, whether that be by hand using the leads method, or there are lots of different tools, including the AutoCluster tool at MyHeritage DNA, which is licensed through the website Genetic Affairs and was developed in collaboration with Everett Jan Bloom. And so there's lots of ways that you can generate these clusters, but essentially what we're doing is we're trying to organize our DNA matches, right? So you take a DNA test, you get this whole long list of autosomal DNA matches, people who are sharing chunks of DNA with you, and because they share DNA with you, we expect that they also share ancestors with you. And we're trying to organize these matches into groups of related individuals. And I point you to this webinar. It's also available for free through MyHeritage. And I'd encourage you to review that for the overview of network methodology, for network theory, kind of what these clusters or these groups of DNA matches represent. We are going to build upon that foundation today. So if you haven't seen this webinar, I encourage you to go and review that. And this webinar will also be available for free afterwards. And so I'd encourage you to watch those in tandem. They really do go quite well together in helping you understand what does a cluster represent. I'm going to do just a brief overview of some of the main takeaways and elements from that presentation as the foundation for today's discussion on really using network methodology to fish in our DNA match lists. So some of the benefits of the AutoCluster tool at MyHeritage are that you can understand relationships between your closest genetic cousins, in whether your genetic cousins or the genetic cousins of a tester. You can begin to understand the relationships between those individuals. You can see groups of people that are often sharing a set of ancestors or several sets of ancestors. Those clusters help to organize our DNA matches into meaningful categories so that we can further explore and determine what does this cluster mean. The AutoCluster is great for helping us understand the lay of the land in the genetic genealogy landscape, for helping us understand who has tested, what ancestral lines might be represented from your own family tree. And it can also help you to detect any situations where there might be a surprise, where you might have a case of misattributed parentage or unknown parentage or misattributed identity. Instances where the proposed genealogy differs from what we're observing biologically in the patterns of the DNA that you are sharing with your genetic cousins. So the AutoCluster has all of these benefits and can give us a really good first pass understanding and organization of your DNA match list. But AutoClusters are just the beginning of some of the possibilities of what we can do with cluster methodology to really narrow in and find the genetic cousins who are going to be most helpful to us in addressing and answering our research questions and achieving our research objectives. And some of the reasons for that are, first, AutoClusters really only focuses on the first 100 or so matches in your DNA match list at MyHeritage. That's probably fine if your first 100 matches, and if you only have a few hundred matches, then that samples a large portion of your matches. But for some people who maybe have thousands of matches, that's just a drop in the pool of the possibilities of how we might be utilizing some of these DNA matches. One of the other challenges in using the AutoCluster report is that MyHeritage actually automatically defines for that AutoCluster what is considered a shared relationship, right? Many of us, if we have any ancestry from any similar populations, will share DNA with a lot of people from that population. And so just the fact that you share DNA with someone doesn't necessarily, equate to a shared relationship. And one of the ways that we can sometimes pierce through the challenges of endogamous communities or locations where there was a lot of intermarriage over many generations is in raising that threshold of what is considered a shared relationship. At MyHeritage, for the DNA match list, right? So we're talking about the DNA match list versus the AutoCluster tool. The DNA match list, anybody who shares any DNA with you, a genetic cousin, anybody who shares any DNA with you and who also shares some DNA with a particular genetic cousin is considered a shared match between those individuals. When MyHeritage takes the match list and imports that data into the AutoCluster, they will sometimes set the threshold of what is considered a shared match relationship to a higher level. So instead of saying, well, anybody who shares any DNA is a shared match, they say, in order to be considered a shared match between you and a genetic cousin under consideration, we're going to say they have to share 15 centimorgans or 20 centimorgans or 35 centimorgans or 50 centimorgans, right? It depends on the nature of the relationships that they're observing in that AutoCluster, and it will automatically update to give you a meaningful report that's helpful. And that's something that they do in order to sometimes pierce through these endogamous communities and create meaningful clusters to help us in these situations. But because the AutoCluster does that, sometimes there will be shared match relationships that we're not detecting as part of the AutoCluster tool because the threshold has been set higher than, say, 20 centimorgans. Maybe a match is sharing just 19 centimorgans with the other match that you're reviewing. In that case, they won't appear as shared matches, even though they do share DNA with each other. So that's one of the shortcomings that we sometimes observe with AutoClusters, and it's still helpful information that we might need to dig a little bit deeper in order to fish out those relationships and obtain that information that can be helpful for our research. And finally, the other challenge with AutoClusters is that the clusters are created based off of genetic relationships to each other. It's just looking at the shared match relationships and grouping those individuals into meaningful clusters. But those clusters can represent several different types of groupings. And some of the most common types of groupings, and one of the groupings that we often look for in these AutoCluster reports and in any genetic network approach, is we're looking for genetic cousins who all descend from a common ancestor and who share DNA with each other and form a cluster of genetic relationships to each other, indicating that you too also probably either descend from that common ancestor of all of the individuals in that group, or you descend from a close relative of that common ancestor. So the uniting element that brings all of these people into a cluster together is their genetic relationships to each other. And sometimes all of them descend from a single common ancestor, maybe from different spouses of that same common ancestor. Other times they might all descend from a common ancestral couple. So Dana Leeds, who is the creator of the Leeds method, which is discussed in my previous webinar, and is kind of an opportunity to do genetic clustering or organization by hand, she describes different clusters as part of, as kind of fitting into several categories. One of those is mountains, and these are mountain clusters, right? Everybody in the cluster descends from a common ancestor, and the shape that that makes is like a mountain. When you map that out and you map out the relationships between everyone, it creates this mountain. So that could be descendants of a common ancestor or a common ancestral couple. But she has also observed, and I have also observed, and as I've worked with these AutoCluster reports, as I've worked with other genetic network approaches, that sometimes clusters represent what Dana calls valleys, right? Where we might have a, so we've got mountains on one side, but we also can sometimes have valleys where instead of everyone in the cluster descending from a single ancestral couple or ancestor, we might have a large subset of the group descending from a common ancestral couple, but then maybe we are bringing in members into that group who are collateral relatives of each member of that cluster, right? So maybe we've got, in this example, we have 5 descendants of Peter and Margaret, and they form kind of the main setup of our cluster. But then we also have 2 descendants of Peter's sister who have been merged into that cluster because they share DNA with that central 5 members. And then we also have 2 descendants of Margaret's collateral relatives, a descendant of her brother and a descendant of her cousin. They share DNA with each other, and they match with those 5 central individuals. Note that the descendants of Peter may not share DNA with the descendant of Margaret's brother or Margaret's cousin. But because they match most of the members of the group, which is formed by the descendants of Peter and Margaret, they are included in that cluster, right? So not always does a cluster represent descendants of a common ancestor or ancestral couple. It's possible that we're bringing in some of these matches from collateral lines. And, so Dana talks about this situation in terms of a valley. Peter and Margaret forming kind of the center of this valley. And if we were to map out these relationships on both sides, you'd see 2 mountains, right? The descendants of Peter's parents and the descendants of Margaret's grandparents. And Peter and Margaret kind of form that valley in the middle. And so that is a valley cluster. So Dana calls mountains and valleys. Something else that I've sometimes come across are mountain range clusters, where you might have an endogamous community where all of the members of the cluster come from the same town or come from the same ethnic minority, and they are all related to each other multiple ways, and maybe not necessarily all from the same common ancestor or ancestral couple or even allied families, but just from the fact that they are part of this endogamous community. I call these clusters mountain ranges, right? We have all of these different common ancestors between different group members, and that is another way, another form of cluster that we sometimes see. So because of this ambiguity of what a cluster might represent from the AutoClusters, sometimes it can be confusing, and it can be, we may not be getting the full value of our DNA match lists if we're just relying on those AutoClusters. Yes, it gives us a great first pass. Yes, it gives us an excellent understanding of the lay of the genetic landscape. It helps us understand the big picture. It helps us detect any problems in proposed relationships, but we can go deeper. And so today I'm going to talk a little bit about a different approach to genetic clustering centered around known ancestral, known genetic cousins, known relatives, and leveraging that known information as bait in order to fish for the genetic cousins that we really need in order to solve our research questions. So what if we instead of relying on automated tools, instead of relying on AutoClusters, which serve a purpose, but may not get us quite to the point that we need for our research questions. What if we instead designed our own clusters in order to fish for pertinent matches? I'm going to go through this methodology where first we identify independent descendants of a research subject. And we'll talk about what I mean by independent descendants. And that first step, identifying independent descendants of a research subject, is our bait step, right? We're crafting our bait to then identify the shared matches to those independent descendants, which is our catch. Okay, so once we've identified independent descendants of our research subject, we search for the shared matches to those known relatives to then identify genetic cousins who could be related through the ancestral lines that we're interested in. Then we analyze those shared matches, and as part of that, we might identify additional independent descendants of our research subject, and we can use that to rebait. And then we identify additional shared matches to those independent descendants, and we get another catch. And as we go through this process, it might be that we only do it once, it might be we do it 5 or 6 or 7 times. But as we do this process and gradually include more and more people into our cluster and into our analysis, then we begin to observe patterns of relationship with more distant shared matches that will help us to identify ancestors and relatives of a research subject. Some of those efforts might be catch and release, but others might be the exact DNA matches that you need in order to address your research question. So as we go through this process, we're going to do this within the context of a research subject, a test subject, and a research question. So in this case, a test subject is a test taker, anybody who takes a DNA test. And we're using those DNA test results to try to answer a research question about a specific individual. Right? So if you were to take a DNA test in order to learn more about the origins of your great-grandfather, then the research subject would be your great-grandfather. We're using your test results in order to learn more about your great-grandfather. And something to keep in mind with this is, in most cases, and unless it is a case of adoption, in which case the test subject is the research subject, right? If in a case of adoption, we don't know who the parents are, we're trying to use a test subject's test results to figure out who that individual's parents are. In many other cases, outside of unknown parentage or adoption, we're using the test results of a test subject to search for information about someone further in the past. Maybe it's their parent or their grandparent or their great-grandparent. And so using the test results of this test subject, let's say that we're looking for their great-grandparents' parents, they're the test subject's second great-grandparents. We are essentially trying to use the DNA that individual inherited from the research subject to answer questions about the research subject's ancestry. And by very nature of that, we're going to be using a subset of that research subject's DNA. If it's your parent that you're researching and who is the research subject, we're using 50% of your parent's DNA to figure out who their parents are. If it's a grandparent, we're using about 25% of their DNA to try and figure out who their parents are. If it's a great-grandparent, if one of your great-grandparents, then we would be using about 12% of your great-grandparents' DNA to try and figure out who their parents are. And that 12% is the DNA that you inherited from your great-grandparents. So, test subject is the test taker. The research subject is the person that we are studying. Now let's talk about what is an independent descendant. If we look at our research subject versus our test subject, then anyone who is descended from our research subject would have inherited DNA from that individual. But for the purposes of clustering, we want to prioritize independent descendants, or individuals who descend from other children of the research subject besides the intervening ancestor between the test subject and the research subject. For the purposes of clustering, this is why we want to look at independent descendants. Shared DNA matches between a test subject and their sibling will include genetic cousins from all of their ancestral lines. So that won't be helpful at all for connecting or organizing and prioritizing and filtering which genetic cousins are related through the research subject rather than through any other ancestral line. And while a descendant of, in this case, the test subject's grandparent, who is also an intervening ancestor, descendants of that grandparent are not independent because those descendants would also bring in genetic cousins who are shared matches to the spouse of that grandparent. And so what we're really looking for here are individuals who have the power to help us filter out and identify which genetic cousins are most likely related through the ancestry of either our research subject or our research subject's spouse. If we can narrow our search to those individuals, then that will give us more power to then identify which of those collateral relatives are potentially pertinent and could help us answer our research question of who were the parents of our research subject. So, an independent descendant is someone who descends from our research subject through an independent ancestral line, meaning that their most recent common ancestor between them and their test subject is the research subject themselves, or the research subject and the research subject's spouse. To demonstrate this principle, I'm going to go through an example from my own family tree. An objective that I've had for a long time has been to identify the biological parents of Anne Lemon, who married to Peter Arthur Rank. Anne Lemon was born on 7th of March, 1821 in Lancaster County, Pennsylvania. She died 11 December, 1884 in Salt Lake City, Utah. And throughout her life, there are many records that report that she was the daughter of James Lemon and Catherine Kaiser. However, there are challenges in documenting the lives and the information on those two individuals. There are several candidates to be James Lemon. There's very little documentation of any women named Catherine Kaiser. And so the objective here is to try and uniquely identify these two individuals within the context of their families to help us understand the context of Anne's more distant ancestry. In this case, I was able to get a test taker who is a great-grandchild of Peter Arthur Rank and Anne Lemon. We know who the parents of Peter Arthur Rank are. We are searching for genetic cousins who might be related through the ancestry of Anne Lemon. So the first step that I wanted to take in this case with this test taker's results at MyHeritage was to find independent descendants of Peter Rank and Anne Lemon, other individuals who descended from Anne Lemon through other children besides the child through whom our primary test taker descended. And some steps that you can take in doing this, and we'll go through these, are to start with AutoClusters and find any corresponding cluster that might refer or might include individuals from the Rank and Lemon families. There's also opportunity to search for surnames, to filter those searches by individuals who have theories of family relativity or smart match hinting. And we'll talk about each of these as we go through this process. Before we go further, I do want to clarify that this is one approach. This is one way that you can utilize clusters in your research. It is not the only way that you can do genetic genealogy research. I have found this approach helpful in quickly identifying which genetic cousins are of interest in a research question, but it's not the only approach, and it may not be the best approach in some situations. I have found this approach to be most helpful in situations where you have a large number of genetic cousins from many ancestral lines, perhaps in situations where there's one group of genetic cousins that are overrepresented because of a very prolific family, and we're just trying to find those needles in a haystack further down in the match lists. I find this approach extremely helpful for historic research questions. If it's an unknown parentage case, if it's an adoption case, this is probably not the approach that I would take. But certainly for historic research questions, this is something that is absolutely beneficial for helping us to get to the DNA matches and to the genetic cousins that are most important to us in our research. So I went ahead and did this approach with our test takers' DNA test results, starting with AutoClusters. So this is the AutoCluster report for our test taker. And you can see that these first several clusters appear to be associated with each other. And you can see that based off of these gray dots that show that there are relationships between members of these clusters and that they seem to be allied with each other. And indeed, this test taker descends from a very prolific family of George Cannon and Ann Quayle, which many of their descendants are represented in this first cluster. But then we also have descendants of Ora Nelson Woodbury and Ann Cannon. So Ann Cannon was a daughter of George Cannon and Ann Quayle, and those are represented here in clusters 2 and 3. And then we have the Lambert and Cannon and the Lambert and Druce families. And then we've got more Woodburys and Cannons, and then more Cannons, Lamberts, and Woodburys. So most of these first clusters are all representative of the test taker's direct paternal ancestry, so the paternal grandfather of the test taker. The entire paternal ancestry of the test taker. The test taker's maternal ancestry, we don't get to that until cluster 9, when we begin to have a few clusters that represent the test taker's maternal ancestry, with the Capson and then the Rank and Lemon family. And what I found as I went through this process was that we have cluster 10 includes 4 individuals who are independent descendants of Peter Rank and Ann Lemon, meaning that they descend from different children of Peter and Ann than the test taker does. We also found in cluster 12 that there were some additional descendants who were also descendants of Peter Arthur Rank and Ann Lemon, but they were descended through the same child as the test subject, and so they're not truly independent descendants. Their shared matches will include members of this Capson family as well. So once we went through that process, we could identify that these 3 individuals actually who were independent descendants of the Rank and Lemon families. Another way that you can search for independent descendants is to search for the surname in matches family trees. So I'm searching for the Rank surname, And we're looking for individuals who have that rank surname in their family trees. And some other things that you can look at, if you click on the filters over here, I forgot to highlight that, but right here with the filters, just two over from the search box, then there's an option to also filter by tree details. And some of the tree details that you might want to take a look at are, do these matches have theories of family relativity, or do they have smart matches between their family trees? These two tools are tools that are unique to MyHeritage. The theory of family relativity tool will compare the family tree of your DNA match, however small it may be, against your family tree, however large or small it may be, and it will also compare those trees against the larger database of records, compiled family trees, and resources at MyHeritage to provide a theory of relationship. It will connect. Maybe your match only has 3 people in their family tree, but that might be enough to start with a small stump of a family tree to then link that to a census record, and link that to a compiled family tree, and link that to another compiled family tree, until we find a uniting thread of relationship between you and your genetic cousin. Another tool here is smart matches. Smart matches will compare your family tree against the family tree of another individual to see if there are any individuals in your family trees that are the same. And that is not necessarily just common ancestors, right? So if you build an extensive family tree going back in time, but then you build forward and identify descendants of your ancestors, maybe the grandchildren or the children of each of your ancestors, and include that in your tree, then smart matches will also connect any people that they see that are the same in both trees, regardless of whether they are your direct ancestor or a collateral relative of your direct ancestor. And that can be helpful because that may be enough to help make the connection between you and one of your genetic cousins to then determine the nature of that relationship. Some other filters that you might want to look at here are, do they have a shared surname, or do they have a shared place in their family trees? All of these can help you narrow in on genetic cousins who may be independent descendants of your research subject, and who can help provide filtering power to identify potentially pertinent genetic cousins. With smart matches and with theory of family relativity, these are tools. These are tools that will generate clues for evaluation, right? So before accepting any smart match or accepting any theory of family relativity as gospel truth, make sure that you evaluate the proposed connections, that you evaluate the amount of DNA that these people are sharing in common with each other, to evaluate whether it really makes sense for them to be related in the way that has been proposed. This is particularly important if only one portion of their family tree is well built, or if the shared relationships between that match and the test taker and the genetic cousins who match both of those individuals appear to be related from a different family line, right? Just make sure that everything pans out in terms of the amount of shared DNA, the proposed relationship, and the shared matches between those two individuals before you accept that theory of family relativity. So when I went through this process to identify independent descendants of Peter Arthur Rank and Ann Lemon, I found 2 second cousins once removed to my test taker in the MyHeritage database, as well as a second cousin twice removed. And each of those individuals were independent descendants of Peter Arthur Rank and Ann Lemon. They descended from children other than the child from which our test taker descended. Well, who are the shared matches between a test taker and independent descendants of a research subject. Other descendants, shared matches with other descendants of a research subject often fit into a few categories. They could be other descendants of the research subject and the spouse, and they might be related through the same ancestral line as that research subject. And that's not terribly helpful because those individuals might be known. They don't give us any they don't give us as good of filtering power because those individuals will also share other ancestral lines with the test taker. And so they're going to have shared matches from those other ancestral lines. And it would, including those individuals would complicate our analysis. Other descendants of, or shared matches with other descendants of the independent descendants of the research subject may be other independent descendants. And those individuals could be helpful because different descendants of a research subject and their spouse inherit different parts of that ancestor's DNA. And because they inherit different parts of that ancestor's DNA, they have different genetic cousins. They have different amounts of shared DNA with key genetic cousins. And so looking at those individuals will help to bring in more genetic cousins into our analysis that are potentially pertinent. So looking at the shared matches with independent descendants may result in the identification of additional independent descendants, which we can then incorporate into our analysis to then broaden our nets and bring in more matches that are pertinent. And finally, other descendants, shared matches with other descendants, either independent descendants of the research subject, could be independent descendants from the research subject alone. They might be other children who are half siblings to the child by which the test taker descends. And that can be helpful because any shared matches between those individuals should be related through the research subject and their ancestry rather than through the subject's spouse. And that brings us to another point here in that shared matches with independent descendants of the research subject may not necessarily be related through the research subject's ancestry, but could be related through the spouse of the research subject. So in this case, we have Peter Arthur Rank and Anne Lemon. Individuals who share DNA with independent descendants of Peter and Anne could be related through the ancestors of Anne, and those are the people that we're interested in, or they could also be collateral relatives of Peter Arthur Rank, who we already know, and we know who his parents are, and we know that family, and we're not terribly interested in that right now. So just because somebody shares DNA with these independent descendants, it's only the first step. We might need to go through another round of filtering to weed out which genetic cousins are pertinent and which ones are not. What we are really interested in and what we hope to find in identifying these genetic cousins who share DNA with independent descendants of Peter and Anne is genetic cousins who are related through collateral relatives of our research subject. Genetic cousins who are related through the ancestors that we're trying to identify. If we can identify and we can filter and we can isolate those genetic cousins and build out their family trees, then we might be able to identify common ancestors between those key genetic cousins who were common ancestors to our research subject or were close relatives of our research subject. And with that information, it can lead us into the documentary evidence to try and better hammer out exactly what the relationships are between these families. So far, we've talked about, these approaches where we've identified independent descendants. We've identified people who are related through, who are shared matches to those independent descendants. And one valuable approach can be to first label all of those independent descendants, label descendants of our research subject who are not independent, maybe who are a niece or a nephew or a sibling or a first cousin to our test subject. And then we can also label shared matches of our independent descendants. We don't know who they are yet, but we know that they share DNA with the independent descendants. We might create filter labels for confirmed collateral relatives of the spouse of the research subject, right? We might say, okay, these are all of the people, we know that these people are related through the rank family. We're going to mark them as rank relatives. And then we could also mark who are shared matches to those known relatives. Something else that can be helpful is to mark confirmed relatives from other ancestral lines and shared matches of those confirmed relatives from other ancestral lines. In this case, if we have a very targeted research question, you might just have a catch-all category for everyone else who we're not interested in, right? That we can kind of put aside and say they are not of interest in our research question. What these filters allow you to do is to identify and sort and filter, not just by inclusion, which is kind of what we're doing with this fishing approach, right? We take independent descendants, we collect all of their shared matches. We analyze those people, identify additional independent descendants, we collect all of their matches. That is sorting by inclusion, right? We're including all of these people. One of the benefits of adding some of these additional filters is that you can also then filter by exclusion or sort by exclusion to say, not only are we bringing in everybody that we're interested in who is sharing DNA with these independent descendants, we're also throwing out all of the people who are related and known relatives of other ancestral lines or who are shared matches to those confirmed relatives from other ancestral lines. So I'm going to go through an example of what this might look like at MyHeritage. So here we have our test taker. We've got one of the independent descendants of Peter and Anne. And what you're going to do here as we're looking at their match page is first, we've confirmed that this person is an independent descendant of Peter and Anne. So we're going to click up here on this individual's labels list. It will bring up this chart or this selection table of the different categories that I've incorporated here. So we have confirmed other relative. That's everybody else that I'm not interested in. We have independent descendant of the Rankin Lemon family. We have non-independent descendants of the Rankin Lemon family. So yes, they descend from Peter and Anne, but they also descend from the Capson family, or they also descend from the Woodbury or the Cannon family, and we're not terribly interested in them right now. We have maybe confirmed rank relatives. Okay, so those are the first four categories are all confirmed relatives or documented relationships. And then these next three categories are individuals who share DNA with confirmed rank relatives, or individuals who share DNA with our independent descendants of Peter, Rankin, and Lemon. And I've created this word here, indescendant, that is just short for independent descendant, somebody who descends from another child of that research subject. And then I also have another catch-all category that is shared with confirmed other relative. Well, in this case, we've identified this independent descendant of Peter and Anne. We're going to go ahead and mark them as part of that label, and then you'll just come down here and click apply, and that will then add them to that group. Next, we go down to their shared match list. And something that I like to do is first come here and click on sort by. You can sort by the shared DNA that all of these matches. So in the match list and in the general MyHeritage interface, this chart will show you all of the matches who share DNA with the test taker and with the genetic cousin that we're looking at right now. In this case, we're looking at an independent descendant of Peter and Anne. So I'm going to sort by the shared DNA with that independent descendant. And we'll get a little later on in the presentation, I'll share some insights into why I sort by that independent descendant's amount of shared DNA with these genetic cousins. So we go ahead and do that, and it will rearrange the list so that it is listed in order of the amount of shared DNA that this person shares with all of the shared matches. Next, you click on these check marks in the shared match list. It will bring up the same label format, and you can click here to mark all of these individuals as shared relatives to our rank lemon independent descendants. And then we apply. And then, we at the beginning of this process, I had identified 3 independent descendants of Anne and Peter, right? So now we go to our next independent descendant. We start with the first one, next we go to the next one, and you'll see here that our first independent descendant is listed as a shared match to our second independent descendant. Well, that makes sense because they both descend from Anne and Peter. We'd expect them to share DNA with each other. And there's some that have been marked as shared matches to our independent descendant number 1, right? So they're already marked in that category. So as you're going through this process, what you may need to do is just mark those that haven't been assigned yet. That will bring up this. We'll say, yep, they are shared to this second independent descendant of Anne Lemon and Peter Rank. And then we apply that. And as you go through this, sometimes you may come across people who have been assigned to, they share DNA with a confirmed rank relative. Well, we'd expect that because these individuals who are sharing DNA with the independent descendants of Peter and Anne have rank DNA too. So we'd expect them to sometimes share DNA with those rank relatives. In some of those cases, what you may need to do is assign people to multiple labels. And you can do that. You'll want to make sure to do that separately from the assignments that you're making for the first time, right? If somebody has no assignment yet, you'll make those assignments first. If they have an existing assignment, you'll want to do those one by one because the interface can get a little bit wonky if you try to do it in a batch like we normally would with the entire list of shared matches. Okay, so then we do that, and we repeat that for our third independent descendant. So now what we can do is if we go to our main match list, and I went ahead and I applied these other filters to some of these other families. I went through and did this for independent descendants of other known ancestral lines and the rank family and to these other lines. And so I've got all of these labels set now for at least the first several pages of my DNA match list. Now what we can do, we go back to our main match list, you click on filters, click on labels, and now we can filter by the labels that we've created. We can pull all of the people who are shared matches to our known rank lemon independent descendants. What does that do? It brings up all of the people who have been labeled with that through our analysis, and we can then begin to identify and work through the list and identify, okay, here's a match who shares DNA with independent descendants of Peter and Anne. Let's look at their tree. Let's build out their tree if we need to. And let's try and figure out who these people are. And like I mentioned before, there's several possibilities of who these people are. So if they are a shared match with the rank with independent descendants of Peter and Anne, but they've also been labeled as a shared match to collateral relatives of the spouse and confirmed relatives from other ancestral lines, then it's probable that they are also a descendant, but maybe a little bit further down, and they're not an independent descendant, right? If they are shared to our independent descendants and to collateral relatives of the spouse, there's a few possibilities. They could be a collateral relative of the spouse, which would not be helpful, or they could also be an independent descendant. So we would want to explore that and try and figure out which of those scenarios is the case. If they are shared to independent descendants, but they're not shared to collateral relatives of the spouse, then they could be a pertinent match. And they could be related through our ancestor of interest. Or they could be a descendant of a research subject by another spouse, or they could be a really distant relative of the spouse and they just don't happen to share DNA with the known collateral relatives that we've been using already to identify these relationships, right? So there's several possibilities of how this might come out, but you can begin to see patterns of when people are assigned to multiple labels, what that could mean in the context of your research question. So I went through this process. I began evaluating each match. And what did we find? Well, we found two non-independent descendants. So we found a first cousin 2 times removed and a first cousin 3 times removed who were shared matches to these independent descendants, but who all descend from the same grandparent of the test taker. So that's not, that won't help us to filter further, but it is helpful information. We also found another independent descendant who we can take their shared matches and kind of build in to then grab more matches, more distant matches who can be helpful for our research question. Some other results from this first round of fishing, right? Our independent descendants were our bait. We put out the line and we got a bunch of shared matches that we began filtering and sorting and identifying. Oh, here's a garbage fish. Let's catch and release that one. Here's another fish that we actually could be helpful. Here's another independent descendant. Let's use that one as more bait, right? We're going to take that one now and go deep sea diving or deep sea fishing to see if we can get the DNA matches that we really, really want to help us identify the parents of Anne Lemon. Some other things that we found, there were some matches that didn't have a tree, that had a really common name that we couldn't quite figure out. So but based off of the people that they were matching, there were some that we estimated this is probably a non-independent descendant, or this one might be an independent descendant, or this one might be a collateral relative of the spouse, right? So you can begin to evaluate even just based off of the people who they are matching. So we take that new independent descendant that we've identified and we use them as the next round of bait. And we expand our net to get more fish, to get bigger fish, to help us explore who are these more distant matches who are distantly related. The closest people we'd expect to our test subject would be third cousins, fourth cousins, or even further. So how do we get those people? We continually go through this process of identifying independent descendants, incorporating their shared matches into the pool, and creating this cluster where we continually fish and build a bigger set of fish. Another way to look at this is snowballing, right? You take a snowball and you begin to add and pack more people into that cluster by inclusion, while you're also considering how to exclude people who are probably not related through the ancestral line of interest. What did we discover as we continued this process? Well, the results of our first round we after that's first round, we got our independent descendant. Next, we did another round, and one of the closest matches to our test taker, sharing about 46 centimorgans, but who in this case was on page 5 of, or let's see, actually was on page, I think, 55 of the test taker's test results at MyHeritage. They were, I think, down in the 252nd match in the list, which would have taken us a very, very long time to get to if we had gone match by match. We found that this test taker shared 46 centimorgans with, this match shared 46 centimorgans with the test taker. They shared 23 centimorgans with one of our non-independent descendants, and they shared 25 centimorgans with our independent, another independent descendant. This individual had an attached family tree, which showed that they were the great-great-grandchild of a man named Robert Lemon, who was born in 1818 in Lancaster County, Pennsylvania, who was the son of Thomas Lemon and Margaret, his wife. They were born in Pennsylvania, but then moved to Holmes County, Ohio. We still haven't figured out the relationship here, but we're looking for the parents of Anne Lemon, and her father was supposed to be a man named James Lemon. And based on the amounts of shared DNA, we expect that James Lemon was probably a close relative of Thomas and Robert. So we found that. What else did we find? We found some additional descendants who descended from a Kaiser family and a Dunlop family in Lancaster County, Pennsylvania. And Anne Lemon's mother was supposed to be a woman named Catherine Kaiser. We don't know exactly how these people are related to each other. Catherine Kaiser's mother, based off of speculative and sometimes unknown information from compiled family trees from the 1880s, was reported to have been a member of the Dunlop family. So we're beginning to see some of these matches that are pertinent, that will help us to explore this family further. And all of this was done in just a few hours. It was done in a few hours because I was doing it for this presentation. It probably would have been a lot less if I didn't have to create PowerPoint slides too as I was going along and doing it. But what this process will allow you to do is more quickly and more efficiently get to the research, the DNA matches and the genetic cousins who are going to help you address your research problem. Now, I mentioned earlier that I like to sort those DNA match lists of shared matches between a test taker and an independent descendant from based on the amount of DNA shared with that independent descendant. And here is one of the reasons why. Just a quick note on distant matches. Distant matches sometimes get a bad rap, and they deserve it. Because many to most small segments that are at least 7 centimorgans and smaller are false, meaning they're not actually shared by the two matches, and they don't indicate shared ancestry. And this information comes from a blog post on the Genetic Genealogist by Blaine Bettinger called A Small Segment Roundup, where he kind of goes through to kind of say, you have those small matches that are sharing just 6, 7, 8 centimorgans with you. They're probably not true. They're probably not, that DNA that you share with those people may not even come from your proposed common ancestors. So why do we care about them? Well, if we sort our match list of, if we sort that match list of shared matches from largest to smallest based on the amount of DNA that they are sharing with the independent descendant, then we're inevitably going to be sometimes including matches who share very, very low amounts of DNA with the test taker. But if a match shares a high amount of DNA with several independent descendants, regardless of how much DNA they do or do not share with our test taker, that is useful information. It still doesn't change the fact that in this case, let's say there's a match who's sharing only 7 centimorgans with our test taker, and they're sharing 25, 40, and 30 with 3 of our independent descendants and 0 with the last. At this point, we don't really care if that 7 centimorgans is valid or not. This person shares a high amount of DNA with 3 of our independent descendants of Peter Arthur Rank and Anne Lemon, suggesting that they are likely related to this group of individuals through the ancestry of Peter Arthur Rank and Anne Lemon. They may or may not be a valid match to our test taker, but who cares? They are valid matches to our independent descendants that we are looking at as we expand our net to include more of these distant matches and evaluate the significance of those findings. I like to compare it in our fishing analogy. If we are looking only at the results of a single test taker and we are being too narrow in our definitions of what may or may not be pertinent and perhaps only looking at matches sharing more than a particular amount, then we are unnecessarily narrowing our focus to a very small patch of ocean in a very wide ocean that could be pertinent to the research questions that we are trying to answer. In the end, some of those fishes, some of those matches that are very distant relatives to our test taker, whose test results we are using, still could be pertinent to the research question if they are sharing sufficient amounts of DNA with independent descendants of our research subject through independent ancestral lines. I'll just close by pointing out that this approach, while we went through it in the context of the interface at MyHeritage, can also be done in an Excel spreadsheet. And MyHeritage allows you to download your match list, and that might be an excellent place to keep track of not just whether a match is a shared match to independent descendants, but how many independent descendants are they matching. You can also use this to sort and organize the lists of shared matches, and you can apply formulas to count the number of times that different matches appear in these different buckets or categories or clusters that we are creating. I hope that this was a helpful exercise in demonstrating one way, a way that I've found extremely helpful in historic research questions to answer and isolate and identify which genetic cousins can help us address a research question, particularly those of a historic nature. Thank you for your time. I hope that this was helpful to you, and I hope that it will expand your view of the possibilities of what you can do with your DNA test results at MyHeritage and beyond as you apply fishing methodologies to design your own clusters as bait to then collect all of those shared matches who are going to help you break through those brick walls. Thank you for your time.
And thank you, Paul. Linda says, a whole new way to look at my matches and maybe clear up a question she has. And Sandra says, Paul has taken this process to the next level as usual. Thank you so much. And lots of other fun comments. Thanks, everyone, for sharing those. Thank you, Paul. And so many people are saying that they want to go back and watch this again. This is where you'll be able to do that up at familytreewebinars.com/myheritage, and the free replay will be there within about an hour after we conclude with the questions and answers here. And then if you want more Paul Woodbury, you can just head straight up there to the website and type in his name. And I'm getting that link for you right here to put in your chat. There it is. And so Paul's got a nice collection of various classes on the topic of DNA and some others. So And I invite you to just go and browse there. If you're a webinar member, you can bookmark them and come back and view them anytime. Oop, pushed the wrong button. And this is our next webinar as part of the MyHeritage webinar series. It will be by Richard Hill on the top 10 DNA features on MyHeritage, and he's put a lot of effort into this, so it should be very good. So I hope that you'll register, and we'll see you then. It's now time for door prizes. We've got a 1-year MyHeritage complete plan for one of you. So this is one of the perks of being here live is you're always entered into. I wish I can give this out to everybody. We're going to say congratulations to one of you, though. Vivian Nielsen. So you're the winner of the complete plan. That's access to everything up at MyHeritage, so you'll really enjoy that. And then let's go to a MyHeritage DNA test kit. And if you happen to be here and your name is, just a second, I'm writing it, Tanya Post, then you're the winner of the MyHeritage DNA test kit. So congrats to you. Paul, we've got a couple of, just a couple of good questions here. Nah, that's not how I meant to say it. We've got lots and lots of comments, so we've got just a few questions here in the list. And one refers back to the beginning when you're talking about AutoClusters and the first 100 matches. Tom's just wondering, what constitutes that first 100 matches? Is this the most, like those that share the most amount of DNA, or how do they end up in the top 100?
Yeah, so the top 100 matches, by default, your match list at MyHeritage is sorted based on the number of centimorgans that you share with your DNA matches. So those sharing the most, the highest number of centimorgans with you will be at the top of the list, and then it will get progressively lower. So it's just based off of those that are in the top 100, and it's top 100 besides your closest matches sharing typically over about 350 centimorgans. The reason that they put that upper threshold is so that you can actually get clusters. If you include, say, a niece or a nephew in your AutoCluster report, then it will just merge all of the clusters together. It'll make one big cluster because everybody's shared with your niece or with your nephew, right? So they are kind of lowering that starting point, and then they will go down from there. The example that I showed you went from about 350 down to about 65 centimorgans, but I've seen others that have gone down as low as 15 centimorgans. It just really depends on the number of matches that you have in your list and what amounts of DNA those individuals share with you.
Okay, Tom writes in thanking you and says makes sense. So thanks, Tom, for your question. Rosa Lynn asks, if your research subject had children by 2 or more people, can you use the descendants of the other spouse as an independent descendant?
Absolutely. And in fact, those independent descendants of just if your research subject had children by 2 spouses, can you use the descendants of the other spouse as independent descendants? The answer there is yes. And in that case, you may want to create a separate label or category for those people, because independent descendants of your research subject and the same spouse through which you descend will have shared matches that are relatives of the research subject and the spouse. We're interested in the research subject. We may not be as interested in the spouse. Independent descendants by the second marriage or the other marriage should have shared matches who are only related through your research subject. So those people are golden. Those people, I think, deserve their own label, because you know that anybody shared with those people has to be related through your research subject rather than through the research subject's spouse.
Very well said. Thank you, Paul. I don't understand this question completely, but maybe you will. And so
Okay.
you just add, this is from Paul. Are there ways to use DNA markers in these searches that are meaningful to our clusters? Can we use them to help determine independent versus dependent descendants?
So by DNA markers, I'm not sure exactly what you mean by that.
Okay.
It could be that you're talking about, the raw data. It could be that you're talking about the segments of DNA that are shared. There's not a way to search by shared segment or by the underlying DNA data.
Okay.
That said,
He writes in saying like that, like the haplogroups as an example.
oh, the haplogroups. Okay, so MyHeritage does not report on the haplogroups. 23andMe does, Living DNA does. GEDmatch allows you to self-report that information as you're uploading there, but MyHeritage does not report on the haplogroups. That information is available at some of the other companies, and you can sometimes filter there. With haplogroups, I would warn against using those as a filter for relationship. It can be helpful. It can provide some helpful information if you're using haplogroups, but it's most helpful when you don't share the haplogroup with somebody, because that can then eliminate a potential relationship scenario, rather than, if you find somebody who has the same haplogroup and has the same surname of Jones, I would warn you against saying, oh, we must be related along the direct paternal line, particularly if it's a common haplogroup. If you want to use haplogroup information, I would recommend, or if you want to use Y-DNA or mitochondrial DNA information, I would highly recommend Family Tree DNA to help with those, because they do offer those tests that are genealogically conclusive for Y-DNA and mitochondrial DNA. The haplogroups can give you clues, but you want to be careful with those.
Okay, thanks, Paul, for your response. He says that helps. Thank you. Paul, it's always a pleasure to have you here. Any final thoughts before we say our goodbyes?
Nope. I just hope that this has been helpful for you. And, like I said, this approach has helped me in being more intentional in designing the data sets that I'm using to help me more efficiently get to the answers in research questions, rather than kind of taking the scattershot approach of looking at all of the clusters and digging into huge networks to try and find a needle in a haystack. I find that this is like a magnet that helps you get that needle a little faster.
Yeah. Well, thanks, Paul. You're welcome here anytime. Enjoy. So I know school's out for kiddos this week, and so enjoy that time, and have a nice summer, and we look forward to the next time together. And we also thank all of you for being part of our webinar today, and you too are welcome here anytime. And remember, life is short to do genealogy first. Bye, everyone. Thanks, Paul.
Thanks.
Mm-hmm.